problem, we needed to determine the number and types of roots for the quadratic functions. We do not actually have to calculate the roots. In order to do that, you need to first look at the form that the quadratic function is in. You're going to have two options, either standard or vertex form. So looking at number 1, I notice that it is in standard form. So when it is in standard form, you could either plug it into your calculator and graph it, see what the graph looks like, or you could calculate the discriminant. Remember, the formula for the discriminant is b squared minus 4ac. And this is simply just the stuff that is written underneath the radical in the quadratic function. If b squared minus 4ac is a negative number, then you will automatically have two imaginary roots. If it is a positive number, you will automatically have two real roots. You have one final option, and that is if it is 0. If b squared minus 4ac is 0, then that means you have a double root. So, looking here at number 1, I'm going to first go ahead and just identify my a, b, and c values. So my a value for this problem is 3, my b value is negative 5, and my c value is 11. So I'm just going to simply substitute in b squared minus 4 times a times c. And as mentioned before, you always want to make sure that you put your b value that you're squaring in parentheses, especially if it's negative. So this would simplify to 25 minus 132. So automatically I could see this is going to be a negative value. If you want to go ahead and plug it in your calculator to see exactly what you'll get, 25 minus 132 is equivalent to negative 107. So since I got a negative answer, I know that I will have two imaginary roots because I cannot have a negative discriminant and get a real answer. For number 2, this problem is a little bit different, reason being that it is no longer in standard form, but it is in vertex form. So when your problem is in vertex form, what you want to do is you want to sketch a picture. Now, you can also plug it into your calculator, graph it, and do it that way, but I honestly think sketching a picture probably takes less time. So to sketch your picture, you need to identify two things. The first being, what is the vertex? So the vertex, remember, is your h and your k value. So I'm going to have negative 4, and I'm just going to have my negative 5. The other thing that you need to identify is the concavity. So in this problem, in order to look at the concavity, you look at the a value, which is negative 3. So negative 3 tells me that this is going to be concave down. So you're going to sketch a picture. Doesn't need to be exact, just a general sketch. My vertex needs to be at negative 4, negative 5, which is somewhere here in the third coordinate. And I know my graph is going to be concave down. So like this. Looking at this graph right here, I could clearly see that this does not cross the x-axis, and it will never cross the x-axis. So knowing that, you could assume that you will have two imaginary roots. All right. And then the final one that we have here, it's 4x squared minus 9. So once again, we have to look at what form it's in. This form is in standard form. So I'm going to go ahead and label my A, B, and C values. Here I have A equals 4. Notice that there is no B value. There is no X in this problem, so B will be 0. And then my C value is negative 9. I'm going to go ahead and calculate the discriminant. I'll have 0 squared minus 4 times my A times my C. You could go ahead and substitute that whole thing in your calculator. We know that 0 squared is just 0. And then negative 4 times 9 is equivalent to positive 144. So 0 plus 144 is 144. The only thing we care about is whether this is positive or negative. In this case, we got a positive answer. So when we have a positive answer, we know that we will have 2 real roots.